In this problem, we are given the current in the inductor is 10 times the cosine of 10,000, which is our omega, t plus 30 degrees, and this is in milliamps. We are given that our L is equal to 20 milliamps. We need to calculate the inductant reactance. We need to calculate the impedance of the inductor, calculate the phasor voltage, and then write a steady state equation for our V of t. First, we're going to start and write the inductance reactance. For this, we can look into the notes, section 9.4, VI relationship for an inductor, and we are going to use the formula that our XL is equal to our omega times our inductance. Now, in writing this, we are going to say that our omega, we can get this from this equation right here, is 10,000, and this is being multiplied by our inductance, which is given right here as 20 milliamps. We need to convert this just to henries, so it's going to be 20 times 10 to the negative cubed henries. And this is going to give us approximately 200. So our resistance is going to be XL is equal to 200 ohms. And that's going to be the answer for part A. Now we move on to part B, where we need to calculate the impedance of the inductor. To calculate the impedance of our reductor, we're going to find Z. And our Z of L, we are again going to use the formula from section 9.4 in the notes linked below the like button, and that's Z of L is equal to J times our W times L. J just represents an imaginary number, so we are just really going to have W times L. And our W we know is our omega, which is 10,000, and our L we know to be 20 times 10 to the negative cubed. Well, we can see that it's the same thing as it is up here. So our impedance of the inductor is also going to be 200 ohms. And that is the answer for part B. Now we move on to part C, and this is a little bit different than what we've done previously. We need to calculate the phasor voltage. Well, we're going to use a formula in the notes linked below right above the other equations, and that is that our voltage is equal to our omega times our inductor times our I max, and then after this we are going to have our angle. We're going to have 90 degrees plus our theta I. Now we're just going to plug everything in that we know. We're going to say that our voltage is equal to our omega. We know our omega to be 10,000, and we know our inductance to be 20 times 10 to the negative cubed. So I'll just copy this down here. Now what's different is our I of M. What is our I of M? We can get this from this formula right here, because we know that the basics for this formula is that the current, so I here, this is our current, I is equal to our I max times our cosine of our omega t plus our theta, and that is the basic equation. So when we look back at what we're doing down here, we can see that we do know our I max, and that is 10. And it's going to be 10 milliamps because we have this milliamps right here, and that's why it's going to not just be 10, but 10 times 10 to the negative cubed, and this will give us our voltage. Now we want our angle as this as well. We are going to have the 90 degrees plus, and we know our theta right here, and that's going to be 30 degrees. So now we can add these together. Our voltage is going to be all of this, and this is going to give us 2. So our voltage is going to be 2, and when we add our degrees together, it's going to give us an angle of 120. So we know our voltage is 2, angle is 120. And since we don't have to add anything here, this is the only voltage, that means we can write the steady state expression for it by just plugging this in. We know that our Vmax is the magnitude, so 2 is going to go in front. We then know that our omega will stay the same throughout, so it's also going to be 10,000, and our volts is our degrees, which is 120 degrees. If we wanted to check this, we could go about plugging this into an equation. We could have our V and then 2 with the angle 120 degrees inside of it, and then set this equal to a 2, and then cosine of our angle plus the J times the sine of our angle. Remember that for all of these, this part right here especially, that J just represents imaginary number. If you want to see how to do the rest of this, there's videos in the playlist linked below, right on top of this problem, I think. that go a little bit more into depth about this rectangular formula to the phasor to the steady state expression formulas. But that is it for this problem. If you want more problems like this, there's a playlist, you can check it out, with all intro to circuit analysis. If you want notes for this material or the entire coursework, it is also in the description right below the like button. And if you have any questions on the material, you can leave them in the comments below.